What we have here is a shape-shifting surface. This particular one will hold its shape in this position, and then I can pull it out and it still holds its shape, and then I can pull it out again and it will stay in that position as well.
A University of South Florida engineering professor is revolutionizing the way things move. And that could be big news to some industries and result in new products and innovations.
One of the ideas I have is to statically balance these, and so that you can hang them all over your body, but the weight's transferred through the structure of the armor that you would have on it, so the person wearing it doesn't feel the weight because the weight's taken up actually in the spring design.
Craig Lusk specializes in compliant mechanisms, which refers to the movement or motion the precision-cut shapes take on when they interact with each other.
The idea behind this is that I have a surface that is very flexible in the plane, can compress, I can expand it, and I can shift it from side to side in a motion that we call shearing.
Lusk has been working for 4 years on the design that he brought with him to USF and has secured funding from the National Science Foundation. Now, he has taken the concept to the next level.
This is built based on the idea of lines bending in a plane, okay, or like on a flat surface. And now if you make things bend all up out of the plane, you can get things that are a little more complicated. Instead of just having lines that move in space, what if I just have, instead of a line, the next thing up is a surface or something that, instead of just a line moving around, have a whole area.
The design includes extremely precise calculations and laser cutting in order to align the surfaces perfectly. Doctoral student Ahmed Al-Qasimi is assisting Lusk in creating multiple variations of the shapes. The idea is that there will be dozens of applications when the surfaces are tiled together. The movement relies on springs inside the mechanisms that balance the plates.
You design the springs in just such the way that they offset the weight, and so it's what we call statically balanced, which means it's happy anywhere you put it. But there's a special type of spring that we call a bistable spring that has two positions that it likes being in. And so we've got a number of these that are what we call multi-stable, or based on this idea, where I have one position where my shape-shifting surface is large and it'll stay in that position, and then it'll snap and it'll stay in a small position, and I don't have to hold the spring in place.
Potential uses for the flexible, durable surfaces include armor that could take the form of a collapsible shield or provide full body coverage, robotics, antennas, and containment structures or barriers. For USF News, I'm Katie Hennig.